The Philippine Army has deployed the U.S.-made M113A2 Armored Personnel Carrier, APC. The vehicle could strengthen the armed forces of the Philippines, AFP, and enhance the country's military campaign against security intruders. The M113 is a military tracking vehicle designed to carry 12 soldiers and a driver. The M113 is a fully tracked armored personnel carrier, APC, that was developed and produced by the Food Machinery and Chemical Corporation, FMC. The M113 was the first aluminum hull combat vehicle to be put into mass production. Much lighter than earlier similar vehicles, its aluminum armor was designed to be thick enough to protect the crew and passengers against small arms fire, but light enough that the vehicle was air transportable and moderately amphibious. The M113's versatility spawned a wide variety of adaptations that live on worldwide and in U.S. service. These variants together currently represent about half of U.S. Army armored vehicles. To date, it is estimated that over 80,000 M113s of all types have been produced and used by over 50 countries worldwide, making it one of the most widely used armored fighting vehicles of all time. The Military Channel's Top 10 series named the M113 the most significant infantry vehicle in history. The M113 is built of 5083 aircraft-quality aluminum alloy. Aluminium alloy is fairly durable, but it still requires nearly 3 times the thickness of steel for an equivalent level of protection, meaning it was only designed for all-around 7.62 mm and shell splinter protection. The M113A3 could also mount applique armor giving protection from 14.5 mm threats and landmines. In comparison, a modern APC such as the Striker has all around 7.62 mm armor-piercing protection, plus 14.5 mm protection on the front, sides, and rear, and a protection against anti-personnel mines. Its weight allows the use of a relatively small engine to power the vehicle, a Detroit 6 volts 53 V6 two-stroke diesel engine of 318 cubic inches, 5,210 cc, with an Allison TX101 3-speed automatic transmission. This allows the vehicle to carry a large payload cross-country and to be transported by fixed and rotary wing aircraft. Original production M113s can swim without deploying flotation curtains, using only a front-mounted trim vane. They are propelled in the water by their tracks. The Philippines already has 114 U.S.-made M113A2 APCs estimated to be worth around $1.4 million for vehicle deliveries. The Philippine Air Force, PAF, has a long history of acquiring United States Air Force assets, including the Bell U-1 helicopter. In 2013, the Philippine Air Force pursued the acquisition of an additional 21 UH-1H helicopters. Despite previous reports of acquiring the UH-1H variant, the UH-1D variant has already been delivered. Of the 21 UH-1D Huey helicopters agreed to in the contract, only 13 were delivered and received prior to contract termination due to delivery delays. As of January 2021, the Philippine Air Force has 13 UH-1H and 10 UH-1D helicopters in service. More than 12 non-operational Huey airframes are stored, requiring spare parts and maintenance. On the 23rd of January 2021, President Rodrigo Duterte announced plans to retire all remaining Philippine Air Force U-1 helicopters due to a series of operational failures involving the type. The Bell U-1 Huey is a utility military helicopter powered by a single turboshaft engine, with 2-bladed main and tail rotors. The first member of the prolific Huey family, it was developed by Bell Helicopter to meet a 1952 U.S. Army requirement for a medical evacuation and utility helicopter, and first flew in 1956. The U-1 was the first turbine-powered helicopter produced for the United States military, and more than 16,000 have been built since 1960. The U-1 has a metal fuselage of semi-monocoque construction with tubular landing skids and 2 rotor blades on the main rotor. Early U-1 models featured a single Lycoming T53 turboshaft engine in versions with power ratings from 700 shp, 522 kilowatts, to 1,400 shp, 1,040 kilowatts. Later U-1 and related models featured twin engines and 4-blade rotors. All aircraft in the U-1 family have similar construction. The UH-1H is the most produced version, and is representative of all types. The main structure consists of two longitudinal main beams that run under the passenger cabin to the nose and back to the tail boom attachment point. The main beams are separated by transverse bulkheads and provide the supporting structure for the cabin, landing gear, underfloor fuel tanks, transmission, engine and tail boom. The main beams are joined at the lift beam, a short aluminum girder structure that is attached to the transmission via a lift link on the top and the cargo hook on the bottom and is located at the aircraft's center of gravity. The lift beams were changed to steel later in the U-1H's life, due to cracking on high-time airframes. The semi-monocoque tail boom attaches to the fuselage with 4 bolts. The U-1H's dynamic components include the engine, transmission, rotor mast, main rotor blades, tail rotor driveshaft, and the 42° and 90° gearboxes. The transmission is of a planetary type and reduces the engine's output to 324 revolutions per minute at the main rotor. The two-bladed, semi-rigid rotor design, with pre-coned and underslung blades, is a development of early Bell model designs, such as the Bell 47, with which it shares common design features, including a damped stabilizer bar. The two-bladed system reduces storage space required for the aircraft, but at a cost of higher vibration levels. The two-bladed design is also responsible for the characteristic Huey thump when the aircraft is in flight, which is particularly evident during descent and in turning flight. The tail rotor is driven from the main transmission, via the two-directional gearboxes which provide a tail rotor speed approximately 6 times that of the main rotor to increase tail rotor effectiveness. The UH-1H also features a synchronized elevator on the tail boom, which is linked to the cyclic control and allows a wider center of gravity range. The standard fuel system consists of 5 interconnected fuel tanks, 3 of which are mounted behind the transmission and 2 of which are under the cabin floor. The landing gear consists of 2 arched cross tubes joining the skid tubes. The skids have replaceable sacrificial skid shoes to prevent wear of the skid tubes themselves. Skis and inflatable floats may be fitted. Internal seating is made up of 2 pilot seats and additional seating for up to 13 passengers or crew in the cabin. The maximum seating arrangement consists of a 4-man bench seat facing rearwards behind the pilot seats, facing a 5-man bench seat in front of the transmission structure, with 2 2-man bench seats facing outwards from the transmission structure on either side of the aircraft. All passenger seats are constructed of aluminum tube frames with canvas material seats, and are quickly removable and reconfigurable. The cabin may also be configured with up to 6 stretchers, an internal rescue hoist, auxiliary fuel tanks, spotlights, or many other mission kits. Access to the cabin is via 2 aft sliding doors and 2 small, forward hinged panels. The doors and hinged panels may be removed for flight or the doors may be pinned open. Pilot access is via individual hinged doors. While the 5 main fuel tanks are self-sealing, the UH-1H was not equipped with factory armor, although armored pilot seats were available. The U-1H's dual controls are conventional for a helicopter and consist of a single hydraulic system boosting the cyclic stick, collective lever and anti-torque pedals. The collective levers have integral throttles, although these are not used to control rotor RPM, which is automatically governed, but are used for starting and shutting down the engine. The cyclic and collective control the main rotor pitch through push-pull tube linkages to the swash plate, while the anti-torque pedals change the pitch of the tail rotor via a tension cable arrangement. Some U-1H's have been modified to replace the tail rotor control cables with push-pull tubes similar to the UH-1N twin Huey. The last use by the Philippine Air Force occurred on January 16, 2021, and after that, all Huey helicopters were grounded for further inspection for the safety of Philippine Air Force personnel.